Vanmôre gesels ons met professor Dr. Markus Depfenhart, alipad uit Duitsland uit. Ons praat spesifiek oor TB. TB in Suid-Afrika, TB in Afrika. Hoeveel TB daar regtig is, weet ons, is ons seker daarvan. Dis nogal skokkend, die statistieke. En ons gesels ook oor 'n nuwe hoop. Is dit dalk die einde van TB met 'n nuwe entstof wat op die horison is? Good morning, doctor.
Good morning.
It's lovely talking to you this morning. Let's first talk about the TB in general in Africa, in South Africa. What is the situation like? What are the statistics?
Look, TB is still a huge problem worldwide, actually, but especially in Africa and here in the sub-Saharan region, it's a real issue. So in the latest stats that we actually have from the WHO is the annual report of tuberculosis. And that states for 2021 that COVID overrun TB, but what we expect is that the major player for infectious disease as killer will be soon again tuberculosis. Probably we will already see that in the new stats of 2022 that we will receive later this year.
So in other words, tuberculosis at this stage has a bigger potential of being a danger for the public than COVID. It is scary if you think about that. We're also programmed with the pandemic that is now taking over, and we think it's the only thing. But tuberculosis is it says in the stats that I quickly looked at, 36% of South African deaths are TB related.
Look, I think it's even worse. Tuberculosis is a real pandemic. It has been totally underestimated. And we see worldwide about 30% of people have been infected with tuberculosis. That does not mean that they become ill. But if we look into South Africa, we see 80% of the population is carrying the pathogen. And one can estimate what that means. So about 10% of the infected people will fall ill during their lifetime, depending on their immune status, and especially when we have co-infections that are weakening our immune system like HIV, the rate is even higher. So tuberculosis is an absolute killer worldwide, and one should not underestimate that.
Wow. I read an interesting article in NBC News in Washington specifically, that the police actually had an arrest warrant for a lady that was infected with TB and that refused treatment because it can spread so easily. And I think so my next question would be, for people that aren't aware of it, what exactly are the symptoms if you have TB? How does it spread so easily?
Yeah, look, it's a respiratory disease, and it's a bacterial disease. It's caused mainly by the Mycobacterium tuberculosis, and that's a bug that has been around forever. And symptoms are like coughing, blood in the mucus, typical respiratory symptoms like fever, weight loss, or some people always have the feeling that they are very hot during night. And if this coincides with weight loss, this is a typical symptom for tuberculosis, but of course can be also a symptom for something else like cancer, for example. But we see those typical respiratory disease symptoms. Mainly the pathology is initially focused on the lung, but it can then also affect the whole body and your kidneys, for example, or other organs as well.
Dr. Markus, you're involved in South Africa, the Walter Sisulu University, the Noord-Wes University, and you're specifically looking into an answer to the TB question, the TB problem. What do you think that answer will be?
Look, I think one has to vaccinate, and one needs a good vaccine that is working well. So the BCG is not working so well anymore, and it was always only working in children, and it didn't last for a lifetime, and now it's not working so well anymore. So we need definitely new vaccines. And for the new vaccines, we have to approach the bacteria different as we approach the viruses. So the viruses are, it sounds a bit silly now, but the viruses are quite easy to attack with a vaccine, because especially with those nucleotide-based vaccines where you give them guidance to build your protein by your own cells, then you just actually replicate what the virus is also doing. So the virus is usually using the host cells to produce the proteins, the viral proteins. And during that, the host starts to learn about the proteins and starts to develop an immune response. Bacteria, they don't need that. So they can produce their proteins themselves. So that means that one cannot attack them like this. And the bacterial proteins evolved very different to the human proteins. And therefore, we have the issue that we usually don't see a good immune response if we use a nucleotide-based vaccine like mRNA or DNA, because the proteins are not the same. What we developed is now a special way to actually go around that typical pathway of intracellular processing. And in so doing, we are not seeing those severe post-translational modification of the proteins that are typical for humans. And as a result, we see very good antibodies, a very strong antibody response. By the way, also a good cellular response, but that makes us very confident, because that strong antibody response is a very good indicator that this vaccine might also be protective. And what we have done by now is we did 2 immunogenicity studies in rabbits with a German partner, and we did a further one, a mouse study that we currently just are about to finish now. And we will start probably, hopefully later this week, with our effectivity study in South Africa. That means with an infectious model, where we will then really see if the vaccine is protective or not. And in about 8 weeks, we will know if this is protective or not. But we are very confident.
Wow. How long would it be before these trials then start on humans, before we start giving these new vaccines that you're working on for humans?
Look, this is always something that depends on the regulatory authorities. So during COVID, we saw that the regulations have been, I would say, weakened a bit. But one would have to then use all the data that we have collected so far. We will do a further study that will be a tox study that is necessary as well. And then we will apply with SABRA and ask them if we get allowance to go into humans. And then they might say, you need to do this again, or you need a further study of this or that, but we don't know yet. But we are very confident that this can happen very fast with the data we already have collected.
It's almost unbelievable that there could be a protective vaccine against tuberculosis, because vaccines traditionally are reactive. It's not proactive. Am I right?
Now, look, I think the term vaccine is totally outdated. And in future, we will think totally different about vaccines. It's exactly as you said. People are just thinking of prevention of diseases, but in future, we will treat diseases with so-called vaccine. I think one has to change the term. And we will see that for cardiac diseases. We will see it for cancer. We will see it for everything. So the term vaccine for prevention of infectious diseases is, from my point of view, totally outdated and is not carrying that weight that it should actually carry.
Dr. Depfenhart, it is truly wonderful to hear that there are such leaps and bounds taken forward, especially now with tuberculosis in South Africa, and hopefully when it comes to DNS type treatment, further jumps in scientific jumps that we can look forward to. And to think that it might even go as far as cancer, like you say, is truly wonderful. Thank you so much for joining us this morning and sharing your insights.
Thank you.
Nou ja, daar het jy dit. Professor Dr. Depfenhart uit Duitsland. Hy wys jou, een van die dae, soos tegnologie nou gaan, kan ons dalk vaksines hê vir meer dinge as wat ons dink. Dankie tog vir mediese tegnologie.